Hello all. In this session, we are going to discuss few programs for 8051 microcontroller. We are going to make use of assembly level programming for solving the questions. Question number 1. Write a program to add two numbers and store the result. If the addition results in a carry, complement this sum, else store whatever answer obtained. So the question tells us to perform addition, and if there is a carry, we have to complement the result before storing into some location. Let us develop the flowchart. So let the two values be present in memory location 50 and 51. So bring them into accumulator and R0 respectively. Perform the addition A plus R0. Load the results in the accumulator itself. Then we have to check the carry flag. And if carry flag equal to 1, we have to traverse towards the right, complement the result, and then store that in some resultant location. And if there is no carry, if cy equal to 0, come straight downward and store the accumulator results into the memory location directly without complementing. So then we can stop the program. Let us code the program using assembly level coding. Starting with org00h, bring the first value to accumulator, get the second value to R0, perform addition using add A, R0. Next, we have to check for the carry flag. Let us use the instruction JC and JC NXT, that is the instruction used here. So if there is a carry, we will jump to the instruction labeled at NXT. And if there is no carry, we will come to the next instruction where we move the answer from the accumulator into one of the location. So here we are using 53 for storing the answer. And after storing the answer safely in the target location, we are branching over to another label part of the code, LST. And next instruction, NXT, that is the label where we come to whenever there is a carry. And at this line, we complement the contents of the accumulator using CPL-A. And after complementing the accumulator content, load the accumulator values in the location 53H. Next line, LST NOP. So LST is another label where we come across SGEM LST. So after loading the answer from accumulator, in the first case, we have to move over to the end of the program. Otherwise, what happens is that we will come to the next instruction where we accidentally complement the contents in the accumulator. So that has to be avoided. Once we have the answer, whenever carry flag equal to 0, we have to load the answer in 53H and then we have to stop the program. For that, we have made use of SGEM LST instruction. Now LST NOP, that is the line we are at now. And coming to the ENT directive. So that is the full program. Let us take up one more question. Write a program to find the largest of two numbers and store the result. So these are the assumptions we are going to make. So let us assume that we have the data set present in 50H and there are 5 number of data, and let the result be stored in the destination location 40H. And we have to note that for solving this program, we'll be using CJNE instruction. The syntax of CJNE instruction is given on the top, CJNE A, B, NXT. And here we have to note that after comparing two numbers, one in A and in B, the carry flag will be set if A is smaller. So that understanding about CJNE is important. Let me repeat. After comparing two values, if the value contained in A is smaller, the carry flag will be set after CJNE instructions execution. So we are starting the program. ORG00H, move R0 immediate 50H, move R1 immediate 04H. So this 04 stands for the number of comparison. We have 5 numbers, so we have to perform 4 number of comparison to come at the final conclusion, which is the largest number. So we are setting a counter with the help of R1. So the initial value will be R1 equal to 04. Move a comma at the rate R0. So we are loading the value that is at 50H. So R1 will be the counter, will be acting as the counter, and R0 will be pointing to the database. Now we are bringing the first data from the database starting at 50 to the accumulator. Next line, INC R0. That means we are incrementing the value contained in register R0. So now the address in R0 will be 51. So R0 will be pointing to 51. Move B comma at the rate R0. The second number from the database will now be moved into the B register. Next, we are proceeding for comparing the value in A versus B with the help of CJNE instruction. CJNE A comma B comma go to. So GTO is the label here. And in the following line, we are going to test for carry, JC next. So if there is carry, it means that A is smaller number. And it also means that since A is smaller number, we have to accept B to the accumulator before we proceed for the next comparison. So JC next. So if we are taking a branching to the instruction label as next, move A comma B will be the instruction that is going to get executed. Let me repeat once again. If there is a carry, it is going to hint us A is smaller number. So we are going to accept B, which is the largest number at the movement to the accumulator. So let us connect the two instructions, JC next, and at next we have instruction move A comma B to accept the largest number to the accumulator. Now going back to the instruction JC NXT. So if there is no carry flag, means that we are safe. We have the largest number in the accumulator itself. So SGEM LP1. So in the line LP1, DJ insert R1 comma BCK. So it means that we will decrement the counter. The DJNS instruction is the instruction that will be decrementing the contents in register R1. So the counter is getting decremented by 1. So that means we are finished with one comparison and we have 3 more comparisons to perform. So we'll branch to the location labeled as back. So back, going to that label BCK. There the instruction is INC R0. So that means we'll be incrementing the register value to 52. Presently it was 51. When we say INC R0, that will get incremented to 52. That means our register R0 will point to the address 53 in the database. So we are going to fetch the third number. So the third number will be pointed to, and the third number will be loaded into the B register, move B at the rate R0. So we will proceed with the second comparison. So the presently largest number is contained in accumulator, and that largest number will be compared with the next incoming data from the database with the help of CJNE A comma B. And this process will be continued for all the 5 numbers, and when R1 becomes 0, we will be coming out of the loop. And when we come out of the loop, move 40H comma A, that will load the largest number that we are holding in the accumulator into the destination location 40. So that is the working of the program, and the last line to end the program is END directive. Thank you.